Okay, so hello everyone, welcome. Can you hear me? Hello. Okay, so we are just waiting for 1 or 2 minutes for joining all of those other participants. Then we'll start. In the meantime, I also give you an announcement for our upcoming online training program. So basically, this training program will be start from the 5th March, and admission last date is the 13th March, and booking last date 14 March. Okay, and first 10 registered will get the 50% discount. So now only 7 seats are available, and this is the time period about this online training program. Okay, so you can see the time period, and basically this class will be held only for the Friday and Saturday in a week. And if you miss any live training session, then you can easily recover using the recorded video class also. You can also get the recorded class also about that. So basically, if you want to join this online training program, live training session, you can simply contact in this WhatsApp number, as well as you can also contact with this email. Okay. So basically, in this online training program, we try to cover all of those things from beginners to advanced level. And if you have no knowledge about the coding section, mainly JavaScript or Python, don't worry about that. You will learn all of those things from beginners to advanced level, and you can easily apply in your research work. So here you can see all of those course content for our upcoming online training program. I already add all of those things in the video description. You can simply check, and further you can easily join this online training program. You will also get some benefits, such as you can get the course certificate, you can get all of those materials like PDF, you can get all of those practice code, you can get all of those recorded class, as well as you can also get the lifetime teaching support. It's very important as a beginner, because when you want to learn the Google Earth Engine platform, you face a lot of problems. So that's why you need the continuous support. So that's why you're also providing the lifetime teaching support. So if you want to join this upcoming online training program, you can simply contact in this WhatsApp number, as well as you can also contact with this email. Then book your seat and join our live training session. Okay, thank you. Okay, so hello everyone, welcome. Can you hear me? Hello.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. Okay, so basically today I will try to discuss about the machine learning model, how we can easily implement using Google Earth Engine platform, and work for the different types of analysis, such as land use, land cover classification. So mainly for the today's session, I try to show you that how we can easily apply the machine learning. And using the machine learning, we can easily do different types of analysis, land use, land cover classification, lot of analysis we can easily do using the machine learning. So let's go. Just I simply share my screen. Okay, can you see my screen now?
Yes, sir.
Okay, so let's go. So basically today is our 6th number day. So yeah. So basically today I also try to discuss about this type of topic. So mainly we talk about the machine learning in Google Earth Engine platform, and how to use the machine learning, mainly supervised and unsupervised algorithm, to make the land use land cover classification map, mainly random forest classifier, then classification regression trees or cart classifier, or support vector machine classifier, or minimum distance classifier, how we can easily use and make the land use land cover classification map. As well as we also talk about the accuracy assessment about our map. We can easily calculate the overall accuracy, kappa accuracy, producer accuracy, consumer accuracy, how we can easily calculate. We also try to discuss about that, and calculate the land use land cover classes area, as well as how to add the legend on your land use land cover map, and finally how to export the land use land cover map from the Google Earth engine and use the ArcMap software to make the land use land cover map. Okay, we'll start discuss about. So let's go. Just I simply open my slide. So basically, in machine learning, mainly in Google Earth engine platform, we can apply the three types of machine learning. One is the supervised, unsupervised, and regression. So basically, in the supervised classification, in this time we need the training sample. Mainly, it's also called the pre-categorized data. Okay, so supervised machine learning model, when you apply, you must need the ground truth example to teach your model to differentiate between the classes. Suppose when I want to make the land use land cover classification map, I want to classify suppose water body, vegetation, build up area. Then I need to take some training sample, and I want to teach this sample. It's a water body, it's a vegetation, it's a build up area. Okay, but when you want to work with the unsupervised classification, then you don't need any kinds of ground truth data. So basically, unsupervised classification, we don't need any kinds of training sample, we don't need any kinds of pre-categorized data, we don't need. So basically, in unsupervised classification, it's mainly work for the clustering. So mainly clustering is one kind of algorithm. It's finding the similarity. Suppose all of those water pixel have a same similarity, all of those build up area have a same similarity. So it's find out the similarities and make the classification. And supervised classification, when you want to do, you must need the training sample, you need the pre-categorized data. And unsupervised classification, you don't need any kinds of training sample, in kind of pre-categorized data, don't need. It's mainly clustering and find out the similarities and make the classes. And regression, so basically regression we are used, suppose when you want to predict anything, suppose water quality or present of the forest cover, cloud cover, or crop yield. So these type of things we are using at the different types of linear regression section. Okay, in linear regression we are apply, and then we can easily predict different types of prediction, water quality, then forest cover. There's a lot of use also for the regression. So now what is the classifier? So mainly classifier, the algorithm which implement the classification on a dataset is known as a classifier. Suppose I which algorithm I implement on my classification. Suppose I can classify the random forest, it's one kind of classifier. Then support vector machine, it's one kind of a classifier. Then classification and regression trees, it's also one kind of a classifier. So mainly which algorithm implement in your classification on a dataset is known as a classifier. And basically we can get the two types of classification, mainly two types. One is the binary classifier, another is the multi-class classifier. So binary classifier we can get only for the two outcome. Okay, so and multi-class classifier we can get that more than two outcome. But binary classifier, it provide you only for the two outcome. Suppose sometime we work suppose yes or no, it's only for the two result or two outcome, male or female, spam or not spam, cat or dog. So it's only for the two outcome we can get the binary classifier. And multi-class classifier we have to use when I need the more than two outcomes. So it's called the multi-class classifier. Suppose I want to make the land use land cover classification of the crop type, classification types of music. So there are a lot of example about the multi-class classifier when we need to use. So in this time we talk about the basically in this time we talk about that how we can easily make the land use land cover classification map. Suppose supervised learning, first of all I try to discuss about the supervised classification, then talk about the unsupervised classification. So basically when you want to make the land use land cover classification map using supervised machine learning model, first of all we have to follow some process. Suppose here you can see selecting your study area, then choosing and filtering the image collection, collecting and the training point, merging the training point, make a training data set, create the classifier, create the classified image. So in this time, I just follow one by one step and also write my code. So then you can easily relate it. So first of all, I just open a new code editor and try to show you one by one. So first of all, our first step is the selecting our ROI, mainly region of interest, which area you want to make the land use land cover classification map. So we already know about that, how we can easily import our boundary area. Okay. So in this time, I simply choose my study area, suppose Dhaka city. I want to make the land use land cover classification map for this study area. So it's my study area. I already uploaded my study area on my asset tab. So now I just simply import these things in here. So now it imported and we find out the default name as a table. So I can simply change it. I put the name, suppose ROI. You can put any name. So now I just visualize my study area as a layer. So use the function map dot add layer. And then call this ROI. Click to the run. It added a layer, but not focus on the center. So for that, I just simply use the function map.centerObject function. And call the object is the ROI, suppose 10. So in this time, it directly focus on my study area. So this is my study area. Okay, I found my study area. So my first step is done. Okay, so selecting your ROI, done. Now we have to choose and filter your image collection. If you want, you can use the Lancet, or if you want, you can also use the Sentinel. Both of time, same process. Just you need to choose and filter your image collection. Suppose in this time, I want to apply the Sentinel image collection. Okay. So for that, I simply go to the browse data catalog. It's a second step. Just simply call on the Sentinel. And we already know about that, how we can easily filtering the image collection, mainly Lancet or Sentinel. Okay. The same process we apply for the filtering, the Lancet or Sentinel, any image collection. Okay. So in this time, we are just focus on the surface reflectance image collection. Click on here. And here I can find out this type of information. Okay, just I simply copy it. Okay, and then paste here. So it's our second step. Mainly it's the filtering. So I just paste here and then give a variable name. Suppose I put the name is that image. Okay. So now this image collection, I just simply filter. So how we can filter? We already know about that. So first of all, we filter, use the filter bounds function. Okay. Filter bounds with our study area, which is ROI. Okay. Then filter, put here the filter. Suppose filter date. Or put here the filter metadata. No, you can put anyone, no problem. Suppose filter metadata. And put here that I choose only for the less than 1% cloud pixel percentage image. Simply copy the image properties and paste here. Then put here that operator less than, suppose 1. Further, just take a variable. Suppose I choose the image for a specific time period. I want to make the land use land cover classification map for you can see I make the year of 2000, suppose 2023. Okay, I take the year 2023, 1st January from year of 2023 December 31. Okay, so now it creates the image collection. Here you can see I just simply print that. Yes, and use the size function. Now it show you how many images are available for this condition, which is the less than 1% cloud cover, and between this time period, year of 2023, we find out total 29 image collection for my study area. In this time, if you want to work for the single image collection, just use the previous method, single image collection, how we show. Just we are simply show you that, suppose print and call the image So now it show you all of those images with their ID. Suppose you want to work for the single image, just simply copy this ID. Okay, copy this ID and work with that. Okay, so basically here you can see this is the ID about that. Simply copy this ID, and then just it's a single date image. So just take a variable, suppose image dot image, and put here this ID which I paste. Just simply paste in here. Now further, I just simply show the layer map dot add layer and call this image. So it's a single date image or single time period tiles now show on your map. So you can see you can get this type of result. Okay, so it's a single date. Okay, so now if you want, you can simply use the clip function, clip with RY. So now it just clip with your study area. Okay, we can get this type of result. So it's a one process. Sometime you also need the single date image for making the land use land cover classification map. Just apply the same process and take the image. Okay, in this time I show you that median composite, because sometime when you want to work for the big region, suppose you want to make the whole country boundary of Bangladesh or any big region, then one tiles is not enough. So for that we have to use the median composite. So in this time I just use the median composite and show you that. But if you want, you want to make the land use land cover classification map for the single date image, just apply the same process. Okay, you can get the image look like that. If you want, you can simply click on here, then you can easily add the band combination. Suppose I put here that B4, then B3 and B2, red green blue, stressing 98%, and further apply. So now we can get the true color composite. We can find out this type of images, single time period. Okay, so in this time I create the median composite. So for that I just use the total 29 image collection and then use it at the median, and it's clip with my study area, mainly RY. Okay, so now I just show the layer about that. So I simply comment these things. So it's need when you want to make the single date image. In this time it not need, I simply show you that median composite. So just I simply call the image and post here the map.layer image, click to the run. In this time it create the median composite, and this median composite mainly take the total 29 images middle pixel value and create this composite. So now I just show the add the band B4, B3 and B2, stressing 98%, and apply. So now you can get the this type of imagery, very better image. Basically this image is the median composite and it's created from total 29 images middle pixel value and create this median composite between this time period. Suppose year of 2023, all of those images which is the less than 1%, all of those images create this composite. So in this time we can get this type of image, and in this time you can see this range is not reprojected this scale value. So for that, here you can see they are already provide the some scale in the band B1. This is, you can see all of this is the same band, same scale. All of band have a same scale. So in this time I simply copy the one scale, and further I just use a multiply function. Multiply this function with this scale value. In this way we are also get the proper wavelength. So in this time it loaded. Yeah, and also finally we add the, click on here, and add here suppose B4, B3 and B2 and customize 98%. So now you can see we can get this proper range about that. Okay, so now further apply. And in this time I just click on the import button. It will be imported a new line. I simply copy this variable name from here and paste after the object name and put the layer name. Suppose it's a imagery. So now our second step is done. You can see our second step, mainly choosing and filtering the image collection. Okay, so it's our second step. So in this time we talk about the third step, mainly collecting the training point. In this time we are used here the supervised machine learning model. Okay, and supervised machine learning model, we must need the training sample, otherwise it's not a supervised learning model. In this time we must need to take the supervised machine learning, mainly we must need the training sample, we need to create the pre-categorized result. Okay, must need the pre-categorized result, otherwise it's not possible. So in this time there are the lot of way to collect the training sample. Okay, if you want you can simply go to the field and collect the training sample. Okay, it also possible, or if you want you can also collect the training sample from your satellite imagery. Okay, so there are the lot of way for import the training sample in Google Earth Engine platform. Here you can see we can easily import it the CSV file also. Suppose you can see the CSV file, we can easily import it the CSV file. Suppose you want to take some training sample, mainly your geolocation data for the different classes, suppose water body, vegetation, and suppose cropland, different types of crop. You want to take the training sample, suppose it's a rice, it's a maize, it's a sugar cane. So different types of field data you want to store in here easily as a CSV file, a specific coordinate. Here you can see you can easily get the longitude and latitude value, you can easily import in here, and further we are just use it as a training sample. Suppose you want to make the crop classification map, so what you can do, first of all you can simply visit your study area or your crop field, you take the some training sample. Okay, and this training sample you can easily import in here. Okay, and further we are use it as a training sample and extract the information from here. So in this time it's a one way, use the training sample, you can simply go to the field and extract the specific longitude or latitude for your specific classes, then you can easily import it in here. So in this time we are using here the band combination method, and you can see it's a true color composite. So basically when you are using the band combination, mainly red, green and blue, we find out this type of image. And now when you want to watch this image, we can easily identify this type of class. You can see it's a water board, you can easily identify, we can easily get the it's a build up area or settlement, you can see this is the vegetation, we can easily identify. And this image is also high resolution because in this time we are using the sentinel image collection. Okay, so it's a very high resolution image. We can easily find out all of those things very easily. So in this time this is my image collection, and I apply the red, green and blue band combination, then I can get this type of scenario. I can easily identify it's a water body, it's a vegetation, it's a build up area, settlement, we can easily identify this this type of barren land, we can easily identify. Okay, but we are also applying the different types of band combination in remote sensing. Suppose one band combination is that mainly near infrared band, then red band and blue band, custom 98%. So now we can get the false color composite. In false color composite, vegetation show as a red color. Okay, we find out the vegetation as a red color, water body show as a dark color. So here you can see for the vegetation we find out this type of red color. Okay, this type of identify about the vegetation, and water body show this type of dark color. Okay, black color or dark color, we can get this type of things. Also you can see we can get this type of gray color for the barren land. So it's a one kind of another band combination. So basically suppose you want to make a land use land cover classification for any place which you did not visit the physically, then what you can do, you are just applying the different types of band combination and try to extract the information from this image and then take the training sample. Suppose in this time I can easily find out this type of red color, identify about the vegetation, so I just consider it as a vegetation, and this type of black color or dark color identify about the water body, so I can consider it as a water body. Okay, and this type of gray color, you can see gray color identify about the barren land, so I just consider it as a barren land or fallow land about that. So in this time it's a one kind of band combination, it's very useful, mainly near infrared band, then red band and blue band. As well as we are also applying the another band combination, it's called the short wave infrared one. then put here the near infrared, and put here the green. Custom 98% I simply put. So in this way we also get the another band combination. It also useful for that analyzing the vegetation. Again, so you can easily get this type of things. And it also useful for identify the cropland. It is very useful for that using this band combination, mainly short wave infrared 1, near infrared, and with free or green band. So in this time we can identify this type of feature. It's a vegetation. We can easily identify about that. It's a water body. We can get this type of color. Okay, you can see it's a barren land or barren land. Okay, and this type of color identify about the wetland also. Okay, we also get this type of things is the wetland, and this type of thing is the barren land. We can easily get dry barren land, and it's a wetland, wet barren land, barren land. We can easily get from here. Also, you can see this is the vegetation. So we can easily get it this type of things when you want to use the band combination. So using the band combination, we can easily identify the different types of feature from the satellite images, as well as we also use here the different types of band ratio to identify different types of mineral. So in this time we are not go to the mineral. So in this time we just make the classification. Suppose I just use the different types of band combination, and now I want to take the training point. Okay, suppose in this time from this satellite images I want to classify, suppose water body, vegetation, build up area, and barren land. 4 class I want to classify. So that's why I need to collect the total 4 training sample. 4 classes for training sample I need to collect. So how I can collect the training sample from satellite images? So you can simply click on the marker. You can see marker, and then click on the edit layer properties, and you can put the name. Suppose I put the name is a suppose water. So put the name is a water. Import as feature collection property. I set the property suppose class, and set the value for 0. Okay, so you can see first of all you can put the name. You can put any name. Suppose in this time I want to take the training sample for water, so I put the water. Import at feature collection property mainly class, and set the value for water 0. So this 0 is the number. Okay, it's a sign about the water. So when I classify and I find out the 0, it means that it's my water class. Okay, so now I simply click to the OK, and now simply select this water. You can see it's selecting, and then you can simply put the some training sample. Just simply take the training sample for water body. And how much training sample you can take, basically it's depend on your accuracy. Suppose after checking my accuracy, I don't find the better accuracy, then I also need to increase the training sample. Okay, so basically first time you try to take more than 30, and then run your model. And if you face if you did not get the better accuracy, then you also try to increase your training sample for your classes. Then this time I take suppose more than 40, and then try to check. I take the water body. Okay, so in this time I take the training sample for water body, look like that. And then I take the new layer and click on here, and put this. Suppose in this time I want to take the training sample for vegetation, so just put here the layer name vegetation, and then further feature collection property name is the same for class, and I set the sign for 1. Okay, so when I want to see any one class 1, mainly it's a vegetation all time. So I then click to the OK. So now I just, you can see this type of is the vegetation. I simply take the vegetation. You can select in the vegetation and simply take this vegetation. Okay, so further we take the training sample for suppose barren land. And set the value for 2. So 2 is always barren land. Okay, this time we are also barren land and wetland. We take the same class. So just I take the smart it barren land and wetland. And when you want to differentiate from the barren land and wetland, just try to take the different training sample for the barren land and wetland. Okay, take this type of things. And further, we have to take the new layer. Suppose I put this, it's this time suppose build up. And feature collection property. Set the property suppose class. And it's for 3. Okay. So 3 means build up all time. So now in this time we take this build up area. And in this time suppose I put here that true color composite. B4, B3 and B2. Custom is 98%. And further apply it. So now we can get that true color composite. Okay, in this time we can get the lot of build up area. We'll just take this training sample from here. Okay, so we take this training symbol for the build up. So in this time you can see we take the training symbol for water body, then vegetation, barrel and build up. So it's our third step. Okay, so you can see I take the training symbol for water body, vegetation, barrel and build up. It also added in here also. So it's our third step. Mainly we collect the training point. Okay, so now fourth step is that we need to merge all of those training sample together. So how I can merge? Very easy. We are just take a variable. Take a variable, suppose samples, and simply merge all of those training sample. First of all, water, merge with vegetation, it merge with barren, merge with build up. Okay, so in this time all of those training sample merge and store it in this variable. So now I just print that and then check what happened. So print and click to run. So in this time it show you how many training sample we can collect for all of classes. 234. Okay, so all of those classes we take total 234 training sample for all of classes. And you can see create the pre-categorized data. Mainly you can see, suppose I want to find out 50 training this point, what is the level. So this level, you can see this level is the 0. Okay, class level is the 0. 0 means what? 0 means it's a water. Okay, so this training sample is for water body. Suppose I just click on here, you can check the what is the level. Level is the 1. So this training sample I train for vegetation because it's the 1, because you can see I put the value for 1, all of vegetation for 1. Also you can see the other, suppose click on here, you can check the class 2. So this training feature I used to train the class 2. What is the class 2? Class 2 is the barren land. Here you can see class 2 is the barren land. So basically this is the process. In this time I pre-categorize. Suppose I just put the label. So this is the common difference between the supervised and unsupervised. Supervised, you must need the label data. So in this time I create the label data. So I put the label data. All of this training sample create the label data. But unsupervised machine learning method, we don't use any kind of label data. So further I also show you that how we can easily apply the unsupervised classification. In unsupervised classification, we don't apply any kind of label. Suppose you can say in this time I put the label. Suppose here you can see what is the label about that. This label is the 3. So this training point I use for 3, mainly build up, because 0, 1, 2, 3. You can see this is the 3. It's a 3. Okay. So in this time here you can see we are just put at the level. So all of the training sample we put the label. So I set my training sample. So it's a one way. We are just put the training point from the satellite images and we are just make the level. Another way is that you can simply import your CSV file with including different types of classes with their specific location. Suppose a specific point location. Suppose you can see it also show about the point, mainly latitude and longitude. It also show in here. So for this point, what is the longitude and latitude, you can easily get from here. So when you want to add your data, you must need to add the geolocation data which have coordinate. Okay, suppose I want to collect the water body. So all of those water body point also their coordinate we have to put in here in our CSV file, and then we can just import in here, and then we are just upload this data, and further we are just click on the import, then it will be imported in our code editor. Okay, so anyone in question? Okay.
No, sir.
Okay, so in this time it's not need. Suppose if you want, you can also start from the 1, because JavaScript is a 0 base, so that's why we start from the 0. If you want to start from the 1, it also okay, there is no problem. Okay, suppose you want to start from the 1, first of all you can put at the 1, 2, 3, 4. Okay, so there is a no problem. Or if you want to put the 0, then 1, 2, 3, it also okay, no problem. But we are also put at the 0 because it's also need. When I want to show you the change detection, then it also help you. Suppose I want to make the change detection, then you can easily understand why I put the 0. And 0 is the JavaScript, it start from the 0 base, so that's why you also put at the 0. But if you want to put the start from the 1, it also no problem. But it also help you when you want to work with the change detection. Okay, suppose when I put the change detection, then we also put the another method. So then we also need to add here the 0, start from the 0, 1, 2, 3. You can easily make the change detection. So that's why if you want start from the 0, it also no problem. Or only for the classification you start from the 1, 2, 3, 4, also there is no problem. Okay, basically it's a label. Okay, so in this time we are put the label, all of those label. So now in this time I put my training point, but in this time each training point I need to extract the information. Suppose here you can see each single point. Suppose this point I want to extract the information. information mainly it's called the spectral signature is band. Suppose I want to extract the information for this band, red band, green band, blue band, shortwave, infrared band, so all of those band. Okay, suppose all of those band I want to extract the information, what's the value, what's the wavelength value for each band, what the pixel value. Suppose for the blue band what's the pixel value, for the green band what's the pixel value for each training sample, each training sample. So for that I just take a variable, suppose bands, and I include all of those band which I want to extract the information for each single point. So in this time I just put here the, suppose I just use at the 10 meter and 20 meter, all of those band I want to use for my model. So I put here the B2, B3, then B4, B5, then B6, B7, B8, and also put the B11 and B12. Okay, so I want to put all of those band only for the 10 meter and 20 meter. Okay, so let's go. We are just simply put here B1, B1. So actually it's my input. Okay, B1, B2, B3, B4, B5, 6, 7, B8, B8A, and put here the B11 and B12. Okay, so in this time I take this type of band. So in this time I want to extract, suppose for this point what the pixel value for all of band. Okay, so in this time it's called the external band. Okay, only which band is available in my satellite images I use only for this band. If you want you can also add the more external band. Suppose if you want you can also add here the suppose NDVI, it's another band we can easily input as the NDVI band, as well as we also inputted the NDWI band, as well as we also put here the suppose EVI band, as well as we also put here the BSI band, as well as we also put here that suppose SAVI band. Actually different types of index we are also use and use it as a band. So why I add this type of external band? Because sometime when you want to work with the crop plan classification you find out very low accuracy. Okay, you check your accuracy is very low, it's lower than 60%. So for that we need to develop our accuracy. So for that we also need to add this type of external band, suppose NDVI, NWI, EVI, BSI, SAVI. And when I add this type of band, then our model accuracy is also developed and we also get the better accuracy. So I'll also show you that how we can easily add this type of external band, and this type of band is already available in my satellite images. Okay, this type of band is already available, but NDVI, NWI, EVI, BSI or SABI or any kind of band you can easily add. So how we can easily add the band I will show you later about that. In this time we are just extract the information only for this band which I use it here. Okay, so I simply all of those band I just make a list in here and store it in this variable bands. So for that I need to extract the information, mainly pixel value for each point. So for that just take a variable, suppose training, I just a variable name is the training, and call my image. So which image I want to use, I already defined my image. You can see this is my image. I simply copy the image and paste here, and then use a function select. I select mainly all of those band which stored it in a variable. This variable name is the bands. Simply copy the variable name and paste here, and then use a function. This function called the sample regions. So basically all time when you want to extract the pixel value from a collection, in this time you can see it's a feature collection, This feature collection have total 234 point, and I want to extract the band pixel value from total 234 points. So it's a collection, it's a feature collection. So when you want to extract the any information from in a collection, suppose in this time it is a collection, then we have to use there the sample regions, this function. So now just put all of those things one by one about the argument, all of these things. So just make a curly bracket, make a dictionary, and also put at the curly bracket in to close the dictionary. So here you can see here in this time collection. So mainly collection, how it's your feature collection. How much? 234, and it is stored in the samples. Basically, this variable is stored in my 234 collection. So I simply copy and paste here. Then properties. So what is the property? Property mainly here you can see when I define the property, I put the class all time. So is all of those classes mainly water, vegetation, barren land, build up, all of those classes we are using the same property name. Okay, so that's why in this time you can see it also show about the properties, mainly it's a plural form. So for that we have to use a list, mainly a square bracket, and put the property name class, because you can see it's a properties, it's a plural form, and all of those classes we are using the same property, mainly class. So that's why we are just put at the square bracket, just make a list and put the property name. Further scale is the resolution. In this time we are just put at the 10 meter, and it's not need, I remove that. And now just print that. Suppose I just print the training and click the run. So in this time it extract the all of those bands pixel value for each single point. Okay, here you can see this result from feature. You can see suppose this point, what is the condition? Here I can get, you can see b1 value, b11, b12, b2. So all of those band pixel value we can get for this point. And what is the level? Level is the 0. So this type of band pixel value for water we find out. Suppose I check the another point, what's happened? You can see this point, we find out all of those band pixel value is bands. And what is the value? What is the level? Level is the 1. Also you can check the another, you can see, suppose you can see all of those band value. And what is the class? Class for 2. And what is the class 2? Class 2 is that barren land. You can see. So it extract the all of those point for their pixel value. Okay, which band I want to add in here. Further, when I want to add here the NDVI, then it extract the NDVI pixel value for all of training sample, or EVI or SAVI or any other kinds of band. When I want to add, it also extract the pixel value for NDVI, EVI or SAVI or any other index. When I want to add it, then it also extract the information. Okay, so in this time it's my training. Okay, so now this is my data set. Okay, so it's my data set. So here you can see my step. We are just merge the training point, then make a training data set using sample region function. Okay, we also done about this part. So make a training data set by sample regions. In this time, after creating this data set we need to split into two ways. This data set I need to split. Suppose some data set I need to use to train my model, and some data set I need to use for check the validation. Suppose this data set, suppose I want to use some data set for train our model. Suppose I use at the 80% data, or put here for test our model we use at that rest of 20% data. Okay, so basically sometime you can check some paper, they are also use at the 70% data, to train their model and 30% data to test their model. Okay, so in this time we put at the 80% data to train our model and 20% data for test our model. Okay, so in this time this data set it's our full data set. So this data set I need to use the randomly distributed 80% and 20%. Okay, so in this time this data set I need to randomly distribute it. So for that I just take a variable, suppose data set, and call this training and use a function, this function called the random column. So basically this random column function randomly distributed this data and stored it in this variable. Okay, so this function mainly help you to randomly distribute this full data set and store it in this variable name as a data set. So now this data set I want to filter 80% and 20%. For doing these things I just take a variable, suppose train set, and call this data set. These data sets mainly filter search engine dot filter dot greater than random 0.8 and take the another variable test set and call this data set and filter it search engine filter is then equal random 0.2. So at this time here you can see we can just take the one variable to store it the train set and test set, and this train set we are used for mainly train our model and test set used for check our validation, what is the performance of our model, mainly check our accuracy about our model. So in this time, okay, so in this time if you have any question about the full code you can ask me. Any question for that train set or test set? Mainly train set we are used for train our model and test set, this data set we are used for check our validation. So now let's check how we can easily add it.